Oh, I love this question. The reason I love this question is because it looks really complicated, but it's not. At the heart of this question, it's just equilibrium, and it gives you all of the information that you need in order to sort this out. It says that the autoisomerization of this axial methyl cyclohexane, number one, to form equatorial methyl cyclohexane, number two, proceeds as described, and it gives you an equilibrium constant. But it's ultimately asking you to figure out what the concentration of, and I'm just going to stop using all the names and I'm just going to call them number one and number two. It asks for the concentration of number two. So I can rewrite this whole reaction as 1 goes to 2. It's an equilibrium. The stoichiometric coefficients are 1. There's an equilibrium constant. It equals 21. Now, the problem specifies that I start with a 5 molar solution of number 1. So it's giving me this idea that I can have an initial concentration of 5 molar. So then what's the initial concentration of number 2? Well, of course, it's 0. So how is it going to change? Well, 1 will be reduced by an amount, x. 2 will be increased by an amount, x. And since the stoichiometric coefficients are 1, they'll be understood. So then what's the equilibrium concentrations going to be? It's going to be 5 minus x and x. So if I were to write down the equilibrium expression, I get that the equilibrium expression is the concentration of number 2 divided by the concentration of number 1, the products over the reactants, raised to their stoichiometric coefficients. And so I have the equilibrium concentrations in terms of x and the initial concentration of each of those. So I can write 21 equals x over 5.00 minus x. And so at this point, it's just algebra, and you have to dust off your algebra skills. Let's work through it. Let's multiply both sides by 5 minus x. So I get 21 times the quantity 5 minus x equals x. Now we're going to have to run that 21 through. So I get 105 minus 21x equals x. So let's go ahead and add 21x to both sides, and I get 105 equals 22x. Now I'm going to divide 22, and I get 4.77 molar. I'm looking for the concentration of number 2. X is the concentration of number 2. And so 4.77 is the concentration of number 2. And that's the solution to the problem. Okay.